When can you trust the code? Well, if you actually have signed code, like in the app stores, you can trust what's being delivered. And since we work a lot with banks and financial institutions, trust is very important. So being able to actually sign a bundle is important. And it's not just the organization that publishes the bundle that can sign it. In fact, they can publish anonymously, and some third-party security audits can look at the code, say, okay, yeah, this is, the code compiles to this, right? So they have the open source code that was shared with them, and they look at it and say, yeah, okay, we've done the testing, and this version is still secure. We do that. That's very important if you start pulling things in, especially when you have package managers. You've probably seen like NPM. There's sometimes a story that it pulls something in that's been compromised because some developer somewhere is responsible for a module, and someone pushed code that then was pulled that wasn't audited by most of these projects. So trusting code is easier when you're getting a bundle that's signed by someone who's audited this thing, right? And that's what happens with Linux and others that are loaded on financial computers. But with the web, we just visit a website and it just spits out code. And it can easily change up the code anytime. So one thing is, if you trust the top-level document that was sent to you, the website, then the web introduced sub-resource integrity, which basically says that the rest of the code or the rest of the resources, images, JavaScript, etc., is going to be pulled from CDNs and other places, maybe other domains which you don't have much control over. But if it doesn't exactly match your hash that you know it should have, then it's rejected. So sub-resource integrity says essentially, as long as I trust your domain, right, I still have to trust your domain to give me that top level document. The rest is, your domain already told me what the document is. The document has SRIs and essentially pulls in trusted resources. Problem is, of course, with the web, except for with the web, you have to trust the domain, the server that serves the domain. It has access to your cookies. It has access to your local storage. It's kind of very powerful. Even though the web sandboxes everything by domain, you end up trusting these domains, and that leads to a kind of a feudalism model where you can't really have self-sovereignty on the web so easily, at least not with normal web browsers. We're going to talk about that in the social impact when we get to the social impact part of this. Okay, so you can see that, like with Cordova and native apps, you can sign the entire app, including the top level documents that will be loaded. So you can trust the local bundle even more than you can trust a website, because with the website, you're still trusting that server that you're visiting, and here you're not. Here, you could have third parties, others, like it's sort of like Zagat food reviewers, right, or whatever, except for security. They say, okay, this gets an A, or, oh, there's a big vulnerability in the version you're running, so get this version, stuff like that. So again, very important for banks and financial institutions to consider this type of application deployment.